Hello, it's Mr. Kaya here, and I'm going through the answer to number 4 from your guys' homework, okay? I'm not going to do number 5 because this is a bad point down here, okay? So skip number 5, okay, because we would have to use decimal numbers for that point down below there, and I don't want to use decimal numbers in order to solve that problem here. Okay, so we're just going to do number 4 here from the homework. Okay, so it says prove that the orthocenter of the following triangle is 0, 3. So what we need to show, okay, that's what that stands for right there. What we need to show is that the intersection of at least 2 altitudes is 0, 3. Okay, so we need to come up with 2 equations such that their intersection, all right, the equations of course would be the equations of the altitudes, but that their intersection is this point right here. Okay, and so like I said in the early instructions, okay, what would be the easiest altitude to use first? Well, I would suggest this guy right down the middle here, right? Okay? We want to use that guy right there, okay? Because that is a good, easy equation to come up with. What is the equation of that line here? All right, now first, that's a vertical line, okay? Down here we have a horizontal line. Let's remember, all right, always, anytime you get a Hoy-Vux, you have Hoy-Vux equations intersecting, they're always going to be perpendicular. Okay, so we got a nice perpendicular line right here, which means that this is our altitude. We'll just call this point down here point D. All right, and so that distance, or that altitude, altitude of AD is 14 units. Okay, and the equation of that line is x is equal to 0. Okay? All right. And so we really don't need this part right here. I don't know why I added this in here, right? This 14 units, because that doesn't prove that the orthocenter is 0, 3, but it goes without saying that if they ask for it, that is our altitude, all right? More importantly, the equation of that line is x is equal to 0, okay, which we have drawn on the graph there. So now we have to pick one of these points, vertices, either B or C, right, and create a perpendicular line, which theoretically will go through this point, okay, and be perpendicular with one of our opposite sides. So I'm going to pick point B, all right? And so I'm going to try to find a line that will hopefully be perpendicular to line segment AC, and hopefully it'll go through that point 0, 3. Okay, so here's our aiming point right here. This is what we're hoping for. Okay, so let's talk about that. So this point down here is -7, -1. All right, and so first we need to find the slope of AC. In order to create a line that's going to be perpendicular to AC, I need to find the slope of AC first. So the slope of AC we can find using this equation right here. Whoops. All right, and so this point up here is going to be 0, 13, and this point down here is 8, -1. So I'll call this one x1, y1, x2, y2. Okay, so -1 minus 13 all over 8 minus 0, and so my slope is going to be -14 over 8. Simplified will give me a -7 over 4. And let's check to be sure. Okay, so I'm going to go down 7 over 4. There's 1, down 7 over 4. Oh, perfect. Okay, so nice. All right. So I'm happy with that. So here's our slope of AC. So the slope of whatever this line that we're going to create that's going to be perpendicular to AC, right, our new slope is going to have to be the negative reciprocal, which is 4, 7. So there's our new slope. There's the point that we are going through. And so we're going to use this equation now. Y minus y1 is equal to m x minus x1, which is just another version of this guy up here, right? And so y minus y1, we're going to use that point. So y minus a negative 1 is equal to 4 over 7 x plus 7. Okay, two negatives in a row. So this guy becomes, whoops, plus 1 here. All right, so I'm going to distribute that 4, 7. Whoops. I'm going to subtract 1. And so finally my equation is going to be y is equal to 4, 7x plus 3. So let's draw that line in right now. Okay, so I'm going to utilize, oh look, what's my y-intercept here? Okay, looks like my y-intercept, should I give myself some space here? My y-intercept is 0, 3. So therefore, the altitude therefore, because 2 of the altitudes intersect, therefore our orthocenter is 0, 3. Okay, so let's just draw that in real quick. So what's our slope? We're going up 4, 1, 2, 1, 2, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So I got 3 points on there. Oh, come on. I thought I was going to do the straight line thing. There we go. Well, there we go. Perfect. So there's our altitude. And as you can see, we're both intersecting at that point right there. And so therefore, because we have two altitudes intersecting in 0, 3, our orthocenter is 0, -3. Okay, so all we need is at least 2 in order to construct that orthocenter, just like we do in the construction. Okay, so as you can see in the construction, all right, in order to create the orthocenter, they only find 2 of the altitudes. Okay, so that's what we did here. We only needed to find 2 in order to show that that intersection is at 0, 3. Okay, so anyway, hopefully that helps. Okay, sorry about number 5. All right, sorry that if you are quarantined and you have to watch this, I apologize. Okay, but hopefully that helps. Okay, alrighty, have a good day.